Okay, good afternoon. Welcome to this Hong Kong U Faculty of Science week. My name is Zhiwen Zhang. I want to give a brief introduction about AI and mathematics. So this afternoon, the talk is very simple. Basically, I will teach you some application of AI and especially this deep learning, like artificial neural network. And during this process, I will show you some mathematics. So first of all, what is deep learning? Deep learning. Well, before machine learning is very popular. Machine learning is very popular, and you have like you do some classification. You want to learn where is the car or not, and based on many people do many feature extraction, and people will develop or set up some feature for the car. Then based on this feature, and people can do machine learning to do classification. That's an old story. But right now, because the computer is very large, very fast, so we can combine these two together. I mean, you just let the computer extract these features by yourself and do the classification simultaneously. So that means you can view this deep learning as an advanced version of machine learning. Okay. So before I introduce the concept, let me show you some application or motivation to see the application of this deep learning and machine learning. So first one is digital recognition. You know, in USA, people write the zip code, right? Different people have different writing styles. So they use this deep neural network to train the machine, and they can recognize these numbers. So for different picture, they can recognize these numbers by the machine. So the input is this picture, and output is 10-digit number, 0 to 9. And also you can use this machine learning or deep learning to do image classification. It give you a lot of image. You train the machine, you train the computer, and they can recognize whether it's a plane, it's a bird, it's a cat, etc. So you can see this network. And nowadays is that they can even, that's a human's performance, right? So see, a few years ago, this machine's performance can overpass human beings' performance. So that means the machine is smarter than people. So for instance, they can recognize some medical image. And another application is speech recognition. They have this long and short term memory neural network, and they can recognize people's voice. For instance, I see some word, and they can recognize this word and can translate the word into translate my voice into text, okay, or translate text into voice. Another example is this so-called AlphaGo. A few years ago, the Google have this AlphaGo. They can beat this world champion Lee Sedol. What is? So there are many development. In old day, people call this. I mean, one time the computer was developed, people try to giving intelligence to machine, and later on, many method algorithm developed for machine learning to do speech recognition, image recognition, etc. And recently, they have a advanced version, means deep learning. Let me show you some application. For instance, in old day, people can, this so-called support vector machine is very useful in machine learning in doing this classification. But nowadays, this AI development, for instance, 13, they have developed this image net. They assemble a lot of database for image. So people can use this data set to train. to train the machine. And the Microsoft develops this for machine for speech recognition and DeepMind and AlphaGo, etc. For instance, you probably know this TikTok, right? They can process the based on users' preference, and they can learn that pattern, and they can decide which kind of video to send for that users, right? Baidu, Facebook. There are many applications of deep learning in this industry world. So that's a lot of that application. Let me briefly introduce some basic mathematics behind this deep learning. Okay, so here let me show you some biology, right? So this is a neuron. Our brain has a lot of neurons, billions of neurons. So here, they have this dendrons like trees, right? And they have cell, and this axon connect to other neurons. So you can view these dendrons like these trees as input. So that you can some information from other neurons translate to this neuron. So that's you can view this as input. Then in this when this neuron gets information, they will do some process in this neuron, and this neuron will process the information to its neighbors. Okay, so that's biology, right? So this called this synapses, to pass the information from one neuron to its neighbors. Okay, so if you this biology. So mathematics is used to model this phenomena, right? So how to model this? You can write this as this abstract formula or symbols. I call this guy as this neuron, and this x1 to xn are the inputs. W1, Wn are the strands of the synapses. Okay, and when this neuron collect this information, it will do some calculation here. Okay, calculation means you calculate the summation and add a bias. Okay, and if this you can view this as value. Okay, if this value is larger than a threshold, this neuron will be inspired. Okay, inspired or excited. Okay, then this neuron will be excited. Then this neuron will translate the information to its neighbors. Otherwise, this neuron will be still inhibited. So that means this neuron has two status. One is excited or not excited. So for instance, if it's excited, you can call this as a 1. Otherwise, you call this 0. That's a very simple starting point. But this is not enough, because in many cases, this be continuous, not a jump from 0 to 1. So then people will introduce this so-called activation function. Okay. So this will give you the neuron a continuous change. Okay. So first, so I hope these slides tell you the basic modeling idea, right? How to use mathematics to model this neuron behavior. Okay, then that's a one neuron. Okay, so you can view this as, if you write this in mathematics, you have this multiplication, summation, and you have activation function f. So this is your output. Okay, if I run this map as a mapping, you can see the map I'm mapping this biology to my model. So this dendron is a trace, right? This collect this neuron with other neighbors. So that's the input. Okay. Then the cell, this is a cell, right? This cell body will do calculation. So it's here, do this calculation, right? Then if the value is bigger, its neuron is activated, then the information will pass to its neighbors. Otherwise, this cell is not activated, so the information will get stuck here. No translation to other neighbors. So I call this activation function. Activation function means if this value is bigger than a threshold, this neuron is activated, so the information will pass. Otherwise, the value is small and we still get stuck. Okay. So in practice, there are several activation functions. One is this one. In older day, people use sigmoid function. Probably in you're a high school student, right? In high school, you probably know this function. If you draw a picture of this function, you can see it's like this, right? So it means if the value is small, it's almost zero, not stuck. And if the value is bigger than some threshold, then this output is bigger, right? So you can decide the threshold to determine whether the neuron is activated or not. Okay, but nowadays people find this function is not efficient in deep neural network calculation. So people propose so-called ReLU function, very simple, like this. It's a max of 0 and x. So it means when x is negative, the value is 0. It's not activated. But when the value is positive, then this equal x. Okay, so you have this. Okay. All right. That's the activation function. So once you know activation function, you can where is this? Okay, you can so that's a one building block. If you combine all these neurons together, you form a so-called artificial neural network. So you have millions, billions of neurons in your brain. So you have this neuron form artificial neural network. Okay, so once you have this neural network, you can use it to train to solve engineering problems, such as do classification, to do estimation. So basically nowadays there are two very useful type of neural network. One is the feed forward neural network. Another one is a recurrent neural network. Okay, the first one is simple to understand. The second one is more useful. Okay, so let me show you some simple structure. Right, you have this this input x1 to xn, right? Then you on each line there is some weight. Okay, so you can please remember our structure here. You have input, right? On each length there is a weight w1 k1 wk2 wkp. That's weight. So in the calculation is you have input value, you multiply the weight and you sum them together. Okay, that's you do in this neural cell, right? So yeah, so in this picture, I show you have this input. Then you on each arrow here, on each line here you have weight. Then you multiply the weight and sum together. So for each neurons, hidden neurons here, you get a value. Then you calculate again. You have this forward propagation. So in this terminology, people call the first layer is input and the last layer is the output layer. In between is hidden layers. Okay. Sorry, this point has some problem. Okay, so here, let me use this picture to explain the main idea. So you have this input, right? And you have two hidden layers. hidden layer 1, hidden layer 2, and output. So for each hidden layer, for each neuron, you essentially do this calculation. See, I just show you for this neuron, and you have this input and the weight, and you do the calculation and you get the value. Then after you get the value, you apply this activation function on this value. So for instance, you can choose sigmoid or ReLU activation function. Then you get the output. Once you get output, you get the value for this neuron. You get new add value for this neuron and this as well. Then you propagate to the hidden layer 2, right? So all these calculations are very simple, very simple. Then finally you get the output. Okay, so that is a very simple setup for the artificial neural network, right? Remember, you know, you have the input, you have output, you have hidden layers. On each hidden layers, you have neurons, and on this connection, you have weight. Okay, so you can see that this as the information propagate from input to output. Okay, so here is the question: what is learning? What is learning? Okay, so learning means I give you some training data, I give you some input and the label, and you use this training data to train. What means train? Means to find the optimal value for this weight, so that you can once this neural network is trained, and you can use this neural network to do like a prediction or forecasting or other things. Means give you another input, you can use this neural network to do calculation and give an output, right? For instance, you use this string. Imagine when you are young, you learn numbers, right? You learn picture, you learn like a voice, right? You imagine when you are young, you learn how to learn 0 to 9, right? You look at picture or write a number, and you essentially is doing this training process. That's learning, okay? Or like image classification, I give you some picture, some cat, some dogs, then you use this to train and to get this weight, and finally you train a network, and you can use that to I give you another picture, and you can do this calculation, and you can tell me it's a cat or dog. Okay, or in more advanced version, you can use this like you use this to train AlphaGo. Okay, you give AlphaGo a lot of previous strategy to beat human being, right? One human being play chase with another human being. They have a lot of strategy. You use this to train AlphaGo. So eventually, you have AlphaGo can beat human being. Okay. That's just not mathematics. So in mathematics, what means train? For instance, yi is the data value, right? This h theta xi is the model, is this neural network prediction. Okay, you want to minimize this error, right? Then you in high school, you know this error, right? You squared and sum together, that's your error. So you want to find a set of parameters theta 0, theta 1 to theta n, such that you get this artificial neural network, and this prediction value and the data, the error is minimized. Okay, that is the training process or learning process. I call this learning. Okay, so I say learning is adjusting the weights on the neural network such that this loss function is minimized. Well, here I show you a 2D picture. You know, you do some search such that you can find the optimal value for W1 and W2 such that this loss function is minimized. Okay, so you will see the optimization mathematical calls like optimization or calculus is very, very important in artificial neural network study. Okay, so I can write this as a mathematical function. I want to find theta 0, theta 1, such that this loss function is minimized. Okay, so you need to solve an optimization problem to get this. Here, I want to emphasize this. Remember the artificial neural network, there are many parameters. So this optimization problem is very complicated. Okay, so here I can show you there is a phenomena so that you can there's a method so-called gradient descent method. But if you run the gradient descent method in optimization, in finding a minimizer for this loss function, you probably, you have some local minimal and a global minimal. So if you start from here, for instance, you do some searching, optimization searching, you'll probably get stuck in some local minimal, and then you cannot move out. But the real or optimal value is here. But if you start from here, probably you get stuck to here. Okay, so you can imagine in this artificial neural network, this study, finding this optimization optimizer or so-called training the neural network is very complicated. So one of the efficient method is so-called stochastic gradient descent method. So people use this. If you do research in this, you have a lot of issues. Like sometimes you have a wrong parameter, you cannot get a good performance in your neural network. So you need to try another one. So this is very interesting. If you are really interested in this, I suggest you to choose this to learn many mathematical course. Okay, so here is a two layers neural network. See, that's it. That's input. Yeah, you're high school, right? So you let me use a simple neural network to explain. So you see, this is your input. That's a weight on this this in between these two layers, right? Then with this input value and this weight, you can do this multiplication and summation. You can get a value for each value on the hidden layer. Then you do this calculation again, you get output, right? So that's a simple illustration. Yeah, so how to adjust? Here is another question. How to adjust this weight? How to adjust this weight? Let me use this picture to illustrate. Okay, so imagine W is your parameter space, and this is your air. You want to you want to find this minimizer, right? Minimizer. Then you do this gradient descent. So that's a data, that's your target. The weight on each between neurons are unknown. There are many. Okay. Now how to update in this optimization course, people develop so-called gradient descent method. So the idea is very simple. You want to find a set of parameter W such that this loss function is minimized. Okay, but how to do that? People use this gradient descent. Means W is, so you can call this W as your current parameter value. Okay, this is not optimal. Then how to adjust this weight? You calculate the derivative, partial derivative of this loss function with respect to this W. You get a derivative. I don't know, in high school, did you learn derivative or partial derivative? If you know this or don't know this, then never mind. I want to tell you that in university, you will learn calculus. But in calculus course, you will learn how to compute the derivative, partial derivative. And you will see this partial derivative is very useful in adjust this weight. That means it's very, very useful in artificial neural network. Okay, so once you get this derivative and you can multiply a sort of learning rate, then you have this formula, you can get a new parameter W. Okay, you do this iteration in an iterative way. So you mean here to here to here to here, eventually you get a minima. Then you finish the training. Okay, you get a very nice neural network. Okay, so let me show you. Yeah, there are essentially two processes in neural network learning. One is a forward propagation. Okay, so forward propagation is this one, right? Once you have this current weight and current value, you do the forward propagation, means you calculate from the input to output, and we call this forward propagation. Okay, so once you have a current output, you can compare let me see where it is. Yeah, you have this model prediction and your data, and you can calculate this difference. Okay, so once you have that difference, you can do a so-called backward propagation. This backward propagation allow you to adjust the weight. Okay, so there's two things. One is the forward. Forward is to calculate the current model prediction, and with this current model prediction, you can calculate the error, and with this error, you can do backward propagation, so you can calculate this so derivative error. This is input. This is a forward propagation, input to output, right? And the backward propagation means once you have this value, and you can do this backward propagation. Essentially, you calculate a lot of partial derivatives. If you are in high school, probably you don't know this. Don't worry. The take-home message is this backward propagation help you get a lot of derivatives. Okay, with these derivatives, you can update your weight. Okay, and then in certain sense, you use this value to train your network. Okay, you do this until this algorithm stop converge, and you don't. That means you get a set of optimal weight Wij. Then you're done. Your training is finished. Okay, your training is finished. Okay, so I read this into an algorithm. Initially, I have a weight, random weight, right? For each data, I do forward propagation, and I do backward propagation. From the backward propagation, I can get this partial derivative, so I can get update my weight. I do this many times until this error does not change. So that means the training is finished. Then we are done. Okay, that's a very simple, probably the very simple introduction for artificial neural network. So for instance, next we enjoy some simple example. You know, what the deep learning do in image classification? You can see, you know, you input some picture, some human being, some cat, some animal, a different picture. Then in these hidden layers, what they do? So in low level, in first hidden layer, they extract some edge information. Okay. Then in second hidden layer, they extract some corners and the contours. And third hidden layer, they can extract some complicated structure. And finally, based on this, they can do classification. Okay, that means give you a new picture. The machine can tell you it's a person or a cat or car. Okay, so see, the first layers, this structure, second layer, middle layer, the upper layer. The simple word is this deep neural network can automatically help you get these features. Okay, in the older day, in the machine learning world, people have to find out or design these features by themselves. But nowadays, the deep neural network just say, you don't need to do that. The machine will automatically do that for you. Okay, for instance, you have this training, you have dog, animal, and in the first layer, get some low level structure, and the higher layer, they get some high level structure. Okay, they can tell you it's a dog or wolf. Yeah, so there are many issues in neural network, like this activation function, and you know, sometimes people, you know, in order to reduce this computational cost, people propose so-called convolutional neural network. Means for each node, they don't connect all the previous nodes. They just connect to some neighbors. This will reduce the computational cost, right? And you know, in order to train this neural network, you need some supercomputer like a GPU computing, right? So in summary, you will see, so what is artificial intelligence? My understanding is nowadays this artificial intelligence you can view as a application of deep learning to do some application work such as pattern recognition, like automatic driving, or natural language processing, social media mining. It's very important, you know. For instance, during the election season, the machine can do some study based on people's preference or some poll result survey. They can predict who will win the election. Okay. There are many applications. For instance, speech recognition. So for instance, you have a GPS, right? GPS, they can tell you some word, right? They give you some voice. That means they can translate text to voice or speech, and face recognition, right? And automatic drive. There are many. You know, nowadays this machine can generate music, generate a photo, or even generate Chinese poetry for you. Okay. So the conclusion is this artificial intelligence will, especially deep learning, will have actually it's already have a major impact on our life. So they have many specialized application in various domains. Probably in future they will replace human being. So my suggestion is from this simple talk, you can see mathematics is very useful in deep learning. One is this derivative calculus study. You will use this to do this backward propagation. This will help you training a neural network. Another application, another mathematics is optimization. Optimization is very useful in this deep neural network training. So I really suggest you, if you want to, if you are really interested in this area, please spend a lot of time to learn mathematics. Okay, so I finished my talk and I'm open to answer your question. You can unmute yourself and ask question. Yes, you can unmute yourself and ask question. Don't be nervous. Any question? Okay, there is one. What do you think the stock price prediction uses mechanism? Yes, I think so. Yes, that's a good question. In the old day, this investment banks, they hire many people to do trading. Nowadays, there's a trend that they they uh, hire a lot of machine. You know how they have a lot of machine. They 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 can train this neural network to train a lot of machine. Let a machine do this trading automatically. Okay, this is they can reduce the cost and they can increase their accuracy. That means, if the machine is trained, they can do everything correctly. Okay, instead of like a human being, sometimes you may hesitate and you make a wrong decision in the trading. Probably you make some wrong decision, but a machine is more accurate than human being. Does that answer your question? Yes. The question is yes. People use this in stock pricing. Yes. Any question? Go ahead. Yes, but is this proven? Any research on this? Oh, that's a good question. The answer is no. This is a very hot research topic. Nowadays, there some simple mathematical problem like PDE solver or optimization solver. They are still have many open problem. So for this stock pricing prediction problem, that's even harder. So many of them are unproven, but in practice competition, they have many good performance. So yeah, if you like this, you can choose this as your research area in the future. There are many research on it. Go ahead, please. Any question? I want know more deep learning. I want to know more deep learning theory behind this. Okay, so the in my personal view, the mathematical theory behind it is optimization and calculus, and also approximation theory. So in order to learn optimization, you need to choose many courses in optimization in any university department of mathematics. In order to learn optimization, in order to learn approximation theory, you need to learn calculus and linear algebra. Yeah, you will learn this basic courses in many mathematics departments. Okay, and in the meanwhile, you need to practice your programming. You need to improve your programming ability. If you can do this too well, you can do this deep learning very well. Does that answer your question? You can, yes, you can unmute yourself and answer. Yes, you can unmute yourself. Yes, thanks. Should I? Yes, you should learn statistics and probability well. Yes, as I said, let me share my screen again. As I said in my talk, in order to reduce this training, people propose, sorry, here, yes. In order to reduce the training, people propose stochastic gradient descent method. So in order to understand this concept, this algorithm well, you need to know probability and statistics very well. Okay? Yes, the answer is yes. Go ahead, please. Do you have any question? Do you have any question? Do you have any question about this talk? Thanks. The major, should I choose SAT or math if I want to learn more about machine learning and deep learning? Both are fine. Both are fine. Both statistics and math are fine. You can choose either statistics or math. Both are fine. Even you choose a CS major is still fine. Computer science is also fine. Okay. But no matter which major you choose, you need to take a courses as I mentioned. Okay, many math course, statistics course, and computer science course. Yes,